So, new chapter today. It's about the same size as our previous chapter. So our first chapter took us about a month and a half here to go through. This one will be around another month and a half. So we'll be finishing up near the end of November, but probably sometime in early December because we have a lot of short weeks coming up. This week's a short week. Next week's a full week, and we have another short week after that, and I think another short week after that. So we got a bunch of short weeks coming up in the next few weeks, which will probably slow us down a little bit. Now, as in terms of difficulty, right? This course kind of goes up and down, right? So the last chapter's difficulty level was by on the medium to lower side of this course. This one's going to be a bit harder, right? And then the next chapter after that, when we started it up in December, most people do really, really well. That's usually one of their best ones after that. So it kind of goes up and down a little bit. And I'll talk about it throughout it. So if you felt last chapter was great, hopefully this one is great as well. Maybe a little bit more work, but if you had troubles last time, maybe come in a little bit more for help, right? Or who knows, maybe this chapter feels different. So this chapter, all right, let's start off with writing our names on here. All right, so we are block D. All right, let's go here. We're block D, all right, and your name. All right. So it's called rationals. Rationals is just a fancy name for a certain type of numbers, right? So there's different kinds of numbers. You started off in elementary school with counting numbers. 1, 2, 3, 4, 5, 6. Those are called whole numbers, right? Then last year they introduced negative counting numbers, right? The negative numbers, 1, negative 1, 2, 3, 4, 5, 6. We're going to do our notes here now, all right? Pay attention to the notes. The negative ones were called integers, right? And last year you worked with rationals, but we didn't say what they were. We didn't use that name. Right? So their rationals is a name for a certain type of number. Those numbers are fractions. So this chapter is working with fractions. And next year when you go up to grade 10, there's probably be another 2 or 3 different names you're going to learn about numbers. And you got to go look at it as a number and say, hey, it's this is its name. It's a whole number. It's an integer. It's a rational. It's et cetera, right? So if you were in my class last year, you're going to have a lot of repeat this year, right? But if you're in my class, you're probably going to learn some new things. So what's different about this year versus last year is maybe the way you do the calculations are going to change, okay? So with fractions, what are we going to learn? We're going to learn how to add, subtract, multiply, divide them, and some bed mass with them. You did that last year. Right? But there are different techniques you can add and subtract and multiply and divide. So the techniques we're going to talk about this year is sort of like the style that you use in grade 10. Right? And there's a couple other things we're going to talk about on top of that. But mostly this is like, hey, last year was the first time you really started working with fractions and we just did the basic calculations. All right? Unless you were in my class, I knew where we were going. So I gave you a little sneak peek. But now it's like, okay, you've worked with it at least once. We're going to give you some other techniques. All right? So today's class is more of a review and a little bit of new stuff. All right? So review and terminology. So the first thing is this word equivalent. I'm sure you probably heard of it, that word, but it wasn't really used a lot. So, lots of times in math questions, if you don't know what the word means, then you get kind of stuck like on the test. You didn't know what repeated multiplication meant. It wasn't a hard question, but you needed to know what it was to do the test, the question. So if I say the word equivalent in terms of math, what does it mean? Samira?
Equal to.
Equal to. Right? Equal to means the same value, right? Equal to. Let's go. 2. Right? Right? And the symbol we usually use is the equal symbol. Right? All those things are connected. So now here's the thing. a number is a number is a number. Sometimes it's really hard to work with a number in one format, and it's really easy to work with a number in a different format, right? So different formats have different purposes. But if we keep the number equivalent, equal, we can pick the easier version to do the calculation we want, right? So one of the things we're going to be talking about in today's lesson, or maybe next class when we finish off the notes, is comparing numbers. Sometimes comparing numbers is easier in one format versus other. For one of the first things I want to talk about is fraction and decimals. All right? You need to be able to switch between those two. See, sometimes it's a lot easier to work with a decimal than it is to work with a fraction. All right? So if I want to take a fraction like this, 3/4, I want to turn it into a decimal, all we need to do is divide the top number, which is the numerator, by the bottom number, which is called the denominator. And I don't know how many students forget that every year. And if you don't like the numerator and top of denominator, you can put the word top on top of here and bottom here. Top number divided by bottom number, right? Easy marks on a test. All you do is grab your calculator and punch in the numbers in, right? So what we need to remember is when we see this fraction symbol here, that is just another way of using this divide symbol. It means the same thing. So a fraction is essentially a division operation. And what you need to memorize is which way do you divide the numbers. You go 3 divided by 4, or you go 4 divided by 3. And you got to memorize the top number first. Right? So we grab our calculator, and you go 3 divided by 4. And you might know this one. I'm hoping you guys know this as a decimal. What's 3 out of 4? Evelina? 0.75. Like 3/4, right? 75 cents. Right? So we go here. If I want to use my calculator, I just go top number divided by bottom number, and I get 0.75. Right? And that is often so much easier to use than 3/4, depending on what calculation we are doing. Right? Now, going forward, in probably grade 10, grade 11, most of your teachers are going to say, we're going to do all of our calculations in fractions, not in decimals, right? Just because when we convert numbers to decimals, often we have to do a rounding, right? And because there'll be a whole bunch of digits, and we go, okay, we're only going to write down 2 of them or 3 of them. Then we have to round. But if you leave the answer as a fraction, it's a more accurate number. It's not rounded, right? So, but it does still serve a purpose. You got to know that this and this means the same thing. So let's try it. Grab your calculator up. Turn both of these into decimals. The first one and the second one, 3/5 and 14/5. Convert both of these into decimals, right? Right? Very calculator using year, right? Grab your calculator, give that a go. Come on, grab your calculator. Here we go. All right? Here we go. All right? First one, you sort of practice, and because I'm asking you to do this because some of you guys' calculators doesn't like to give answers as decimals. If you go 3 divided by 5, the answer will spit out a fraction, 3/5, and it won't change. And so you need to know what button to push on your calculator to turn it to a decimal. So if you go 3 divided by 5, you should have got 0.6. And if you divide by 14 divided by 5, you should have got 2.8. Now, if your calculator gave you a fraction back at you and you don't know how to turn it to a decimal, put up your hand. I'll show you where that button is in your calculator, right? So your button is this one right here. So you do go 3 divided by 5, it equals, and you just hit this button. Okay? Anybody else? Just the one person did it? Oh, okay. Excellent. All right. So next up. Okay. Sometimes it's a lot easier to work with decimals. But I may give you a decimal and ask you to go backwards and say, hey, can you turn this into a fraction? Right? And your teacher probably talked about it last year. It's not something we do a lot of because you usually just have fractions and stay in fractions, but we need to be able to go the other way. So if I had something like 0.3, does anybody remember how to turn that into a fraction? It's probably like one lesson, your teacher talked about it for like 5 minutes, and you may have most likely forgotten. I'll be very impressed if you remember. Anybody? Okay. Gage? 0. 0 is not the same thing, right? Right? 0 is not the same thing as 0.3, right? So, when we have a fraction, we need a top number and we need a bottom number, right? And these need to be, should be no decimals in there, right? All right. So the top number is going to be what you see here without the decimal. So 3. Okay? 3 divided by a number is going to be 0.3. So the bottom number is always going to be a number that sort of looks like this. 10, 100, 1,000, 100,000. A 1 followed by a bunch of zeros. A 1 followed by a bunch of zeros. And the trick is, how many zeros do you put down? Is this jogging some memories, Brooklyn? You know the answer? How many zeros? Do you know how? Do you know how to figure out how many zeros? Nope. Okay. So, how many decimal numbers you have is how many zeros you add in. There's one decimal number here, so we add in 1 0. Right? And if we grab our calculator, you can always double check. You go like, oh, I'm not sure if I remember that rule that Mr. Dhaliwal was talking about on the very first day of our notes. Because we're going to do this test in December. You may forget about it, right? Just grab your calculator and double check. So, okay, did I do it right? I go 3 divided by 10. 0.3. Okay? All right, let's do the next one. We have 2 numbers. We have the top number and the bottom number we need. The top number, what we see, right, without the decimal. So you don't usually have zeros in front of numbers, so that's just 48. Negative 48 in this case. Negative 48. Then we go a 1. Yes?
It would be 2 zeros, it would be like 100.
Yeah, so this one will be 2 zeros. We have 1, 2. 1, 2. All right? And we're going to double check with our calculator and make sure we did it right. So if we go negative 48 divided by 100, oops, divided by 100, negative 0.48. Okay? Just a little trick you have to memorize. Next number. What do we write on the top? Huh? You usually don't start numbers with 0, whole numbers with 0, right? We look at this and we go, oh, just 24. All right? So I'm going to write down 24. Bottom number, 1, followed by how many zeros? Yes, Brooklyn. 3 of them. There's 3 spots. All right? 1, 2, 3. 1, 2, 3. That's it. All right. So now, that technique works for like 85% of them. And then there's some tricky ones that sometimes students get kind of like, oh, what's going on here? Right? Let's try a different one that we haven't seen so far. What if I had, let's go underneath here, 1.05 like this. And I wanted the fraction of that. So that's our number, and we want to turn it into a fraction. All right? What's our decimal? Oh, so no, sorry, not a decimal. What's our top number that we write down? Take a guess. This is different than the other ones, right? All right. Just the same thing I said. The number you see without the decimal. So 105 this time. All right? 105. Then the denominator, we have a 1 followed by how many zeros? 2. There's 2 spots after the decimal, right? So 1, 2, right? You're not sure, use the calculator. 105 divided by 100. 1.05, the number you're looking for. All right? One more. Let's do another one of these. Let's go 2.040. Gauge? 2040, that works. What up at the bottom? 1 followed by how many zeros?
3.
1, 2, 3. 3 spots. 1, 2, 3. All right? So you go 1, 2, 3. You do that. All right? 2040 divided by 1,000. 2.04, where you started off. Okay? So there might be some odd ones that we kind of throw at you, right? But if you kind of follow this procedure, you should get the answer. Use your calculator to double check, right? And if it doesn't give you the answer, like, okay, where did I go wrong in my thought? This is an odd situation. What's a little bit different about this versus the other ones, right? If you can't figure it out, then you call me over for help. All right, good. So, key thing here is these are not different numbers. They're the same number, just in a different format. They are equivalent. They are equal to each other. We use one way, sometimes we use another way, another time, whatever makes our life easier or whatever the question asks for. Right? They're not different numbers. So many students start fixating, oh, this number is different than this one. No, it's in a different format, but it has the same value. Right? It's like saying, hey, you came to my house and you mowed my lawn, and Lorcan's like, hey, I charge $50. Right? I could give him $50 in tens, or I can give $50 in fives. I'm paying with different kinds of bills, but at the end of the day, he's getting the exact same value. Right? So the number is still the same, right? All right. Okay, so that's what today's lesson is about, is converting from one number format to another number format, just to make our lives easier in certain situations. So, sometimes we have numbers that look like this. A big giant number out front, then followed by a fraction. This type of number has a name. Does anybody know what kind of fraction this is? There's 2 types. Yes?
Mixed number?
This is called a mixed fraction. All right? So it's a fraction mixed with a whole number. Right? Now, for the vast majority of my class, we're not going to work with these numbers. These mixed numbers are typically harder to do calculations with. So we turn mixed numbers into a different kind of fraction. Those fractions are called improper fractions, right? Where we have no number out front. All we have is a fraction. A number on the top and a number on the bottom, right? So we need to convert, oops, Control Z. We need to convert these things, right, into an improper fraction. Right? There was a procedure for this. Does anybody remember how to convert a mixed fraction to an improper fraction? Right? Yes?
Multiply like the whole number on the side of the denominator and add it to the numerator.
Yeah. So when we're doing this, what a fraction is out of never changes. It was out of 3, it's out of 3. Right? We're just trying to figure out what the new numerator is. And Evelina had the procedure right. So every teacher has different ways to do this. I like to draw these little arrows. We multiply these two, then we add that. So you take the bottom number, you multiply it to the number on the side, so you have 1 times 3 is 3, then you add the 2, and we get 5. Right? So our fraction is 5 over 3. Okay? Now this is called an improper fraction because the top number is bigger than the small number, bottom number. Numerator is bigger than the denominator. So that's like a no-no. You shouldn't have that. And the answer is this, they want you to write it as a mixed number when you come to that format, but it is so much harder to do all your calculations in that format that my class, we're going to convert everything into this format. Your final answer is going to be in this format as well. Right? Unless I say, hey, this one particular time I want you to practice going the other way. So we're going to go this way so much faster. Right? This is usually easier for adding and easier for multiplying and dividing, working with these kind of numbers. All right? So let's practice this. We have 3 examples here. All right? What it's out of doesn't change. The first one's going to be out of 3. The second one's going to be out of 5. The last one's going to be out of 7. Your job, figure out what the top one number is. Multiply, then add. Use your calculator or do it in your head. Give you a couple of seconds here. Shouldn't hopefully take too long. Right? Multiply, then add. Dylan, give it a try. Orkin, give it a try, man. Right? Everybody knows. Come on. Right? You need to. All right. You need something to come back to be able to do. All right. Anybody get the first one figured out for me? The last one's a little tricky. All right. What's the first one? 1 times 3 is 3. Add the top number. Yes. 4. Yeah. 4 with the excellent. Times, then add. 4. 1 times 3 is 3. Add the 1. The next one. Multiply, then add. 9 times 5, we get what number? 45. Thank you, Wyatt. Plus 2, we get 47. Okay. The last number. Okay. Before we do it, I want you to realize that these numbers are the same numbers. We're not changing this into some other magical new number. It's just a different format. So if I had this as a decimal, right, I have 1 and a third, right? So if I did the third as a decimal, I'd go 1 divided by 3 is 0.333. Then the 1 in front would give us 1.333, right? And if I go the other format, I go 4 divided by 3, I should have the same number, 1.333, right? We're not changing what the number is, just changing how it looks to suit our purposes. The purpose is to make our calculation easier. Alright? Right now it doesn't feel easy, but that's what the overall goal is. Last one. Multiply, then add. What should we have for our numerator? Anyone think yes? Samira?
Negative 22.
Negative 22 over 7. Let's give it a go. So 3 times 7 is 21. 21 plus 1 is 22. Right? Now if Samira did it correctly, if we turn this number into a decimal and turn this number into a decimal, we should have the same answer. Right? And let's see. Let's grab my calculator. I go 1 divided by 7 is 0.14. Then I add the 3 in front, and I get 3.14, and so on. So you do 22 divided by 7. We should hopefully end up with the same number, except for the number should be negative, right? She did it correctly. But the last one there, I'm glad she did it correctly, is the one where most of you guys are going to make mistakes. Because what a lot of people are going to do is they're going to go 7 times negative 3, and it's negative 21, and they're going to add the 1, and then they're going to say negative 20 over 7. And that's the very common answer. And if you go 20 over 7, 20 divided by 7 is not the right answer. Right? So whenever you have a negative out front, ignore it when you're doing the calculation and just slap on the negative at the end. So you go 7 times 3 is 21, plus 1 gives us 22, then slap on the negative at the end. Okay? Ignore in converting. Right? Multiply, then add. Okay? And it's not just like 1 or 2 people that make that mistake. There's a lot of people that make that mistake every year. And usually you're pretty good when I talk about it in the lesson. You're like, okay, I got it. But, by the time we do the quiz, so that'll be next week sometime. So I only see you twice this week. Right? Some of you guys will forget it over the weekend. Maybe this is going to be a long weekend. We have Friday off as well, right? So I won't see you guys until I see you guys Monday and Wednesday this week. Then I don't see you guys till after Wednesday the following Monday. All right? Almost a full week away. Okay, let's do a couple more. We're not going to do the back page. I think that's too much for now. Let's just finish off the front page. You want to call it a day? I'll give out some progress reports and stuff like that. Okay, so now we do need to be able to go the other way. So if I give you an improper fraction, we do need to be able to write it the other way. Okay, and this one's a little bit harder to memorize the steps. Right? So remember, what a fraction is out of doesn't change when we're converting it. So first one's out of 5. This one's going to be out of 5. Right? So now there's 2 numbers we need to figure out. We need to figure out the number out front and the big number up top, the numerator. Right? So the number up front is a whole number. Right? We're trying to figure out how many full times can 5 fit into 13. How many full times can it fit in? Twice, right? You do the multiples of 5. 5, 10, 15, 20, right? So 5, 10. It fit in 2 full times, right? There you go. 5. So you sort of go like that. You go 5 can fit into 13 twice. But there's going to be leftovers. Right? So 5 times 2 is 10, and this leftover. We want to get to 13. So we need another 3 more to get to 13. So 5 fits in twice, and we need a 3 more to get to 13. Right? So that's it. Right? It's a little bit harder. Now, the hard part, I think, in this one is to figure out what the whole number is. And if you're struggling with ever figuring out what the whole number is, you can use your calculator. Use the decimals. You can go like this. You can go, hey, 13 divided by 5, and it says, hey, it fits in 2 full times and a little bit left over. So you know your whole number is going to be 2. Right? So then you go 5 times 2 is 10. What's the leftover? I need 3 more. Okay? Let's do the next one over here. Do some practice ones. All right, so for all of these, the bottom number doesn't change. 5, 10, and 7. We need to figure out the whole numbers and the numerators, the top numbers, for each one of these, right? So either you're really good at your multiplying, you know how many times it fits in, or you use your calculator to help you, right? 5 fits into 12 how many times? Thank you, twice. Or use your calculator, 12 divided by 5. You got a big 2 sitting there with some left over. Fits in twice. So 5 times 2 is 10. How many more left over? Dylan? How do we get to 12? 10 to 12. How many more do we need to add? I know, that's why I called on you, buddy. Right? We need, Brooklyn, you're right, 2 more. Right? 5 times 2 is 10. And we need 2 more to get to 12. Okay, let's do the next one. 10 fits into 32. How many times? 3. So 10 times 3 is 30, right? Fits in 3 full times, right? So that gives us 30. How many more do we need to get to 32? 2 more. 32. All right. Next one. 28. 7 fits into 28 how many times? Thank you. 4 times. How many are left over?
1.
No.
No.
None. Because 4 times 7 is 28. Well, none? 0. Or our answer is just 4. Because 7 fits into 28 perfectly. Right? Okay, we'll stop there. And